What's up, guys? Clearly, I'm not going to be in today. Um, we just have, some notes to do here. All right, this is the next section. Trying to make this as good as possible here. Guess that's as good as it gets. All right. Hide this. There we go. Okay, so we talked most recently about the normal distribution, which is a continuous distribution. It is theoretical. It's a model which we use to model what we see out in the real world. But what we usually encounter, at least personally, like on an individual level and individual studies, we end up with discrete distributions, meaning, like histograms and things like that, as you saw inside your project when you went to take a look at stuff. We can, of course, reference the normal distributions and things like that, these continuous distributions, but they are, of course, just theoretical. And the more of a sample we have, right, the greater the n becomes, the more like a theoretical distribution things tend to behave like. But when we encounter small numbers of in our sample and in studies, they're typically discrete. So we're going to be discussing how to find the mean, variance, standard deviation, and expectation, which we'll talk about today, for discrete distributions. So the mean, variance, standard deviation for a probability distribution are computed differently from the mean, variance, and standard deviation for samples. Additionally, we are adding a new measure, which we call expectation, in this section. To find the mean for a probability distribution, you must multiply each possible outcome by its corresponding probability and find the sum of the products. As usual, what we'll do is we'll do this by hand first, and then I'll show you how to use your calculator in order to do it, which hopefully you guys learned on last benchmark. You probably want to learn how to do before the day of the test. So the formula looks confusing and tough. The formula for the mean of a probability distribution, okay, the mean is equal to the value of my first x variable times the probability of observing that value of the x variable plus the value of the second, and so on and so forth, right? Okay, so you're just basically taking that value of x, multiplying it times the probability of that x. And then you're just going to sum them. If this looks familiar, it's because it should. This is essentially the formula for a weighted mean. And the weight here is simply the probability. Okay, so find the mean number of batteries sold over the weekend at a convenience store using the probability distribution below. We've actually, I think, done this exact same problem, just through a different lens. So the mean would be equal to 2 times 0.2 plus 4 times 0.4 plus 6 times 0.32. Okay, plus 8 times 0.08. All right, so let's see what this product is. Nope, wrong way. All right, we have 2 times 0.02. Oh, sorry, just times 0.2. Plus 4 times 0.4 plus 6 times 0.32 plus 8 times 0.08. I forgot to set a little timer for myself here. I don't want to make this too long. Computer, set a 20-minute timer. So we make sure I don't go over 20 minutes for you. Computer, set 18-minute timer.
18 minutes, starting now.
We've been talking for a little while. All right. Oop, my face is covering the answer. That's 4.56. That's my mean. Stop for a moment, make sure that calculation looks reasonable. It is within my range, so it's kind of right in the middle. Looks reasonable enough to me. Find the mean number of spots that appear when a single die is tossed. So that's kind of an interesting way of phrasing it. Let's go ahead and produce ourselves our own table. We can do this from our head. Oh, I have to take this. Oh, what do I do? What do I do? Trying to figure out how I can stop this recording real quick. All right, sorry about that interruption there, guys. Where were we? Right here. Okay, so the values are either going to be 1, 2, 3, 4, 5, or 6. I know you guys don't play cards, but hopefully you can remember that each of these are 1/6. Right? So let's go ahead and compute the mean here. Okay, so hopefully you can appreciate there must be an easier way of perhaps putting this in. And of course, that would be if I factored out the 1/6, right? And then I could just, if I wanted to, I could just add these up. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, that's 21. Okay, so we find that the average is 3.5 theoretically. Okay, so we would say something along the lines like the mean value rolled is 3.5, theoretically. Clearly, you can't actually roll a 3.5. Okay. All right. If 3 coins are tossed, find the mean number of heads that occur. Okay, so we have to create our table first. And that would require that we know those values. Remember how many? Well, if we toss 3 coins, you can have 1 head, you can have 2 heads, or you can have 3 heads. Do you remember the probability associated with each? Well, how many possible outcomes are there? There'd be 2 possible outcomes, 3 times the power of 3. So we have 8 possible outcomes, remember? How many of them have 1 head? How many of them have 2? How many of them have 3? So if you don't remember this, you're going to have to maybe create your probability tree, right? Oop, that's a tails. Okay, so now we have one way of getting that's 1 out of 8. One way of getting 3 heads, right? How many ways do I get 2 heads? There's 1, 2, 3. Oop. Yep, looks like 3. Okay, which means that the other way must be the remainder, right? 4. Okay. Let's just double check that. 1, 2, 3. Huh. Did I make a mistake here? I must have made a mistake. How many have just 1 heads? Oh, wait. There's the 4th. 1, 2. Oh, I'm only counting 3. What's going on? Huh. I'm messing up. I gotta pause the video and make sure I catch my mistake here. My bad. We forgot. Well, I shouldn't say we. I should say me. Well, I'll leave those there. I miscounted. That is 3, but I forgot that there's a way of getting 0 heads. Duh. And there's only one way of that happening. That's all tails, right? Silly. Okay. So let's go ahead and find the mean. That's 0 times 1/8, which is clearly 0. 1 times 3/8. 2 times 3/8. We have 3 times 1/8. That goes away. And let's probably just type that in. So we have 3/8. Parentheses around that, plus 2 times 3/8, plus 3 times 1/8. 1.5. Kind of makes sense because you expect there to be half, right? If there's 3, you expect 1.5 heads. Clearly, you can't have 1.5 heads, but theoretically, that's what you get. So the mean number of heads in 3 tosses. Well, actually, with flipping 3 coins is 1.5. And it kind of makes sense because it's, a half probability, half chance of getting a heads in each row. So different way of looking at it. All right. Variance and standard deviation. Formula for the variance of a probability distribution. This is a little bit different. Find the variance probability distribution by multiplying the square of each outcome. By the way, we square it so we don't have to worry about negatives. Right? We worry about basically magnitude difference from the mean. By its corresponding probability, right? So that's its likelihood of departing from the mean, summing those products and subtracting the square of the mean. So essentially, we are looking for distance from the mean again. So on average, how much do our values differ from the mean of the distribution in either direction, right? Looking for basically distance. So the formula for the variance is such, and it looks confusing, but all we're doing is we're summing, right? This symbol means sum. We're summing the square of each value, right, which gets rid of the sign, times the probability of that value appearing, which makes sense because it's the weight, and then we're going to take that sum and subtract the square of the mean. We squared the mean just to put it on the same order as the squaring of the values here. Okay, of course, the standard deviation is just the square root of the variance, and that's just if you had put the square root over top of the previous expression right there. All right, so best way to compute the variance is through the use of a chart. I would actually disagree. I mean, I think we have to create a chart in the calculator as well, but we will use the calculator to do this variance stuff after we do it a couple times by hand. Okay. All right, so compute the variance standard deviation for the probability distribution below. Our values of x are 1, 2, 3, I'm sorry, 1, 2, 4, and 8. Am I missing something? No? Okay. X squared, that'd be 1, that'd be 4, that'd be 16, that'd be 64. Probability of x, 0.18, 0.29, 0.41, and 0.06. Now we have to multiply these. So that'd be 0.18. It's easy enough. I have to use my calculator for this one. 4 times 0.29, 1.16. That's 0.41. 6.56. Then I have 64 times 0.06. 3.84. Now we're going to sum that. Okay, take all those and add them. So 0.18 plus 1.16 plus 6.56 plus 3.84. Oops. All right. Yep. 11.74. All right, we've got to actually find the mean. Oops. We've got to find the mean here. We got to go ahead and find that mean. Okay, so that's just going to be the outcome times the probability again, right? So that's 1 times 0.18 plus 2 times 0.29 plus 4 times 0.41 plus 8 times 0.06. The mean is 2.88. I'll keep going the wrong way. Computer, stop. Computer, stop. I'm going to give you guys a couple more minutes on this because I know I lost some time with the phone call. So let me go back to I have here, okay? So the variance would be equal to that sum minus the mean. I have to do the mean squared. So 2.88 squared. 8.2944. Okay. Ooh. I'm just going to write it out the first time because I think it's kind of nice to know. So that would be 11.74 minus 8.2944. Okay, so our answer for the variance is 3.4456. And let's go ahead and find the square root of that. It's actually sometimes easier just to exponentiate by a half, and that would be 1.856. Okay. So this says on average, right, we would expect the values to depart from the mean by about 1.9. Okay. All right. Let's do one more example, and then we'll call it a day. Okay. A box contains 5 balls. 2 are numbered 3. 1 is numbered 4. 2 are numbered 5. Okay. Balls are mixed. One selected at random. After ball selected, this number is recorded. Then it is replaced. If the experiment is repeated many times, find the variance standard deviation for the ball on the number of balls. Okay, so that's a key, right? Anyway, let's go ahead and just do this. So what possible outcomes do we have? We have the number 3. We have the number 4. And the number 5. Probability of getting a 3 would be 2 out of 5. Probability of getting a 4 is 1 out of 5. Probability of getting a 5 is, again, 2 out of 5. Okay, let's calculate that mean, and then we'll square it. So that's 3 times 2, or 0.4, plus 4 times 0.2, plus 5 times 0.4. Okay, our mean is 4, which means our mean squared is clearly 16. Okay, let's go ahead and do this table here. Outcome of 3, 4, and 5. X squared would be 9, 16, and 25. Probability of x, that's 0.4, 0.2, 0.4 again. And then we have to multiply those. It sure is a windy day today. Man, a lot of windy days recently. Things are blowing all around out there. I hate it when the windy days coincide with recycling day, and you end up with like bottles everywhere. It's a terrible day for me. Anyway, so I actually ended up adding them. So, oops. Whilst talking, what I ended up doing was I multiplied each of these and added them at the same time. So I only had the sum. Sum is 16.8. Okay, so my answer here, you can find out what these are, but the sum, which is important, is 16.8. So the variance, that's not variance, this is variance, will be 16.8 minus 16. So my variance is 0.8. And that means that my standard deviation would be the square root of that. Square root. Huh, 0.89. I'll take it. Okay, which means on average you would expect things to differ by about 0.9. All right, we will call that here today. I have not made an ALEKS assignment for you yet. I will soon. I know that I didn't make that ALEKS assignment posting recently. I'll make sure I put that up there as well. And we'll finish up these notes and do some calculator work tomorrow. Okay? All right, guys. Let me figure out how to turn